The daily oxygen consumption of a bird embryo increases from the time the egg is laid through the time the chick hatches. In a typical galliform bird, the oxygen consumption can be approximated by the function C of t equals negative 0.065 t cubed plus 3.4 t squared minus 22 t plus 3.6 milliliters, and this is the daily oxygen consumption, so this is per day. This model is only good for t between 8 and 30 inclusive, where t is the time in days since the egg was laid. An egg will typically hatch at around t equal 28. We're going to use this model to estimate the following: the daily oxygen consumption 20 days after the egg was laid, the rate at which the oxygen consumption is changing 20 days after the egg was laid, and the rate at which the oxygen consumption is accelerating 20 days after the egg was laid. On the surface, it might seem that these three parts are similar, but they are not. The first part asks us to find the daily oxygen consumption, which is given by the model. The second part asks us to find the rate, which is the derivative, and the third part asks for the rate at which the oxygen consumption is accelerating, which means that we will need the second derivative. So to answer part A, we will need to use C of t, which is given. To answer part B, we will need to find derivative C prime of t. And to answer part C, we will need the second derivative C double prime of t. For part A, we simply plugged in 20 into the function C of t, which means everywhere we see a t, we will replace t with 20. So this will be negative 0.065 times 20 cubed plus 3.4 times 20 squared minus 22 times 20 plus 3.6. Using a calculator, simply type this expression after the equal sign into a calculator. We will get 403.6, and the unit will be milliliters per day, daily. For part B, we're looking for the rate which the oxygen consumption is changing, so we would need the derivative C prime of t equals the derivative of the first term is negative 0.065 is a constant multiple, so we would rewrite it, times the derivative of t cubed is 3t squared, plus 3.4 is a constant multiple, so we rewrite it, the derivative of t squared is 2t, minus the derivative of 22t is 22, and the derivative of 3.6 is 0. Before we plugged in 20, we're going to simplify this. Negative 0.065 times 3 is negative 0.195. Bring down t squared. Plus 3.4 times 2t is 6.8t. Bring down negative 22. Then we simply plugged in 20 into C prime. This will give us negative 0.195 times 20 squared plus 6.8 times 20 minus 22. Plug this into a calculator, we will get 36. And the unit is milliliters per day and then per day. What this means is that each additional day, the daily oxygen consumption will increase by 36 milliliters per day. Specifically, after 20 days, the oxygen consumption was 403.6 milliliters each day, but for each additional day, that amount increased by 36 milliliters. For part C, to answer the question about accelerating, we will need the second derivative. The second derivative is the derivative of the first derivative. And so the second derivative is negative 0.195 times 2t plus 6.8, where we use the simplified version of the first derivative to find the second derivative. Simplifying this, we get negative 0.39t plus 6.8. And then we plugged in 20 into the second derivative. This is negative 0.39 times 20 plus 6.8, and we'll get negative 0.1. The unit will be milliliters per day each day, and so per day squared. What this means is that at this rate, 36 milliliters per day each day, the rate as with the oxygen consumption is decelerating, and so it is increasing, but it is increasing at a slower and a slower rate.